Hello, it's Greg. Since the last video, I have worked a little in the background on our dotbim exporter from Tekla. And there is a new class, exporter. And the main thing which this class do is orchestrating the whole process. So here we have the references of all of those previous factories or objects which are needed to grab object from Tekla, transform it into our domain objects, and later export to dotbim file. So all of that is here, and that class, it will be the main input point, and it will do all of those inner stuff. Because in the first videos we were creating those small bunches, those selectors from Tekla, transformers, tessellation, and exporter. But in the end, our users want to get the streamlined approach. So they want to have something selected in Tekla, or they want to operate on the all objects, and then they want to get the dotbim file. That's all. They don't want to, move those pieces by hand. So this is the main purpose of the exporter. And there is also one very dummy test, and it just export the selection into the file on that specific path. So currently there is no such a file, and as you can see, it is working with the export mode set to selection. So let's select something in Tekla, for example, those objects, that ramp, and then let's try to run that test. So here it is, let's run it, and we will see that it will fail or it will succeed. And at the end, we will get the file, and we have some error. Oh, why is that? Let's see what is wrong. So we are getting the problem with, we are working on the release mode, because if you see such a statement coming from the initialization of the delegate proxy from the Tekla library, then it means that you have no connection with the Tekla. And if your Tekla is running and it is the only process and all you think is correct, then probably something is wrong with your configuration of the project. So let's go to the debug. Later I will show you why it works on the debug and it is not working on the release. But yeah, let's try once more. And now, after waiting a while, now we see the green tick and we have the dotbim file. So let's try to see it with one of those three exporters. Let's use that one, and I will now just... Okay, so those objects were selected by me from Tekla. Okay, it works somehow. But the question is, how long does it take to export the whole model? How we can check it? So let's just try to select it, and let's once more run the test, and we will see what will be the duration of that test, how long it will take. And probably it will take quite a long time, and it will be the point when we will start to think, okay, so how we can increase the improve the performance, how we can squeeze the time needed to export Tekla objects to dotbim, because now probably you don't hear my fan on my laptop, but it, yeah, oh, okay, we have it, but okay, I have run all of them. So okay, sorry, it was my fault, because I have run not only that one particular, that one, let's reveal in the test explorer, here it was. So that one, which we wanted, it took 23 seconds to obtain the dotbim file for that model. Quite a lot of time. And the question is how we can do it a little better. Let's see that it will work or not. And yeah, sometimes that free viewer, oh, okay, I just needed to wait a while until it will grab all of those triangles, and now we see the our Tekla model in the dotbim format in the web viewer. Okay, here it is, and yeah, those are those little scaffolding elements. Okay, so what I want to achieve, I want to somehow get better insight why it is taking 23 seconds, where is the hot path, and can we do anything, for example, convert those points from classes to structs, because from the first side it can be beneficial. We don't know it. It's just, a grasp. You feel that, yeah, maybe there we could save our time. So the question is how we can try to squeeze that time. And usually when you are dealing with some performance issue, you need at the very beginning some better insight. Okay, so where my code is taking so much time. And here, when we have that exporter class and it is split into 4 different fields, 4 different objects, which every of those, it do something different. So we can measure the time for all of them. And the simplest way how you can do this would be just to insert some stopwatches, measure the times, and then try to investigate, okay, so where it takes so much time. And let's try it with that some very simple approach, a little naive, but okay. So I have the method export, and here we are getting elements from Tekla, we are querying their data, whatever it means, and then we are creating the dotbim file. So we have 3 different operations. So let's start with the most simplistic idea. And please, I'm just trying to replicate how usually we are starting, but it's not the best approach. Later I will try to show you what is the much better approach. So I will start some stopwatch, and it is in the system diagnostic stopwatch start new. Here it is, and that stopwatch it will measure the time elapsed. So we will want to grab those elapsed milliseconds, and they are long. Okay, so let's also initialize some list with the long type, and here after every quite important stuff, I will add the elapsed time, and after that I will also restart the stopwatch. So I want to do something like that. And yeah, I will do it also for that part and also after saving, and here I will just say stop. And I will put the debug breakpoint here, and I will try to run that unit test which exports the selection to stop at that point, just to see, okay, so what are the times? And yeah, I feel, but okay, let's try. So now I am debugging, and it took 23 seconds at the beginning. And now, probably I don't have anything selected. Yeah, I don't have anything selected. So we have not hit the breakpoint, and the code probably, it just stopped execution at that return invocation. So now let's wait those 23 seconds, and yeah, we will see the list of those times. So based on that, we will be able to say that, okay, maybe that part was the longest one, or maybe that one, or maybe that part, because we are adding 3 time spans in a row. We see that the process memory goes quite significantly. There are many garbage collector invocation. So yeah, we are creating a lot of points inside, but okay, I want to see those times. So let's see them. We have 3 elements, and we see that getting those objects from Tekla, it took me 4.5 seconds. But this query element data, it took the most. It was the longest operation. So based on that very simplistic system diagnostic stopwatch, I am able to say that, okay, the problem lies somewhere here. But where? In the transforming, in the getting meshes, or in the getting the color from the Tekla? It starts to be a little problematic, because now if I would like to measure that, then, more stopwatches with some, here we have the for each loop, so it would be a little troublesome to get it. It can be done, of course, but please wait. The stopwatch should be used only for that point, just to, okay, so I have a problem with inside of that method. Where exactly inside of that, I don't know, based just on the time. It's not enough. So there is a better approach. And to do it better, at the very beginning, we need to realize that measuring the performance in the debug configuration is not the best one, because usually when you are providing your clients, your users, the version of your code, you're doing it in a release, and the release version is a more optimized one. So there is a lot of things going under the hood, not on directly what you see in your code, but between your code and intermediate language, which is the backbone of the .NET framework. So when you are measuring the performance, you should do it in the release configuration. So now I would like to see that, okay, how the time will be split in the release configuration. But to do that, I will just, at that point, just want to not put the breakpoint and stop the execution and see what is going on, but I want just to provide some console write line, or maybe even debug. Not sure, we will see at the very beginning with that. So I want to create some kind of a message that it took, and here I want to merge, to join. I will use the string join for those times, and that will be that. Now at the beginning I need to provide the separator. So here I need to provide how they should be merged, and I will do this by that. I think that something like that, it will be fine. So I want now to display that message. And why I am doing that? Because I want to see here in the results of my test that statement, just to not be pushed to put the breakpoint and see what is going on. So now, after a while, we will see that, we will see or not, we need to wait to those 23 seconds. I'm not sure that it should be here the console or debug. So we will see, probably rather the console, because here we see the output from the console. So let's wait a while, and yeah, we see what was the split between different operations. And of course, I think that we also need summary, just to times sum, and yeah, it will just provide us the summary time of the whole operation. Okay, but of course this is for the debug. It always takes 23 seconds. And the problem is, as you saw at the very beginning, that on the release mode, when I am trying to run, that test will fail. The fail will be very, very quick. Test was aborted, so let's do it once more time. Do I need to rebuild all of the project? Probably not. Okay, yeah, we have the problem, because there is no connection with the Tekla. And the question is why? What is the difference between the release and the debug configuration? And the problem is related to the Tekla 2024. If we look what we have imported at the very beginning from the packages, it was this ts-app-config patcher task, quite a big one. So here is something which is done just after your compilation, or somewhere between. I think that it is done after prepare for build. Okay, so yeah, it's sorry, it is before. So what is going on here? Here, some magic library, some magic method from the Tekla, from the Trimble library is invoked, which is doing quite a lot of stuff in terms of applying, of pointing the Tekla libraries to your code. So where those Tekla structures model, Tekla structures, and all of those DLLs, where they can be found. The easiest way to make it running, maybe not according to idea of the author, but just for the purpose of, okay, so let's find out how much quicker our code will be in the release mode. So to do that, we need to modify the CSPro, our project file for our test. And here we need to specify the Tekla version. And I think that it was the target Tekla version, no, just the Tekla version. So what I have added? I have added the new property, which will point that I want to have it set up for the Tekla 2024. Also in the release mode. And after that, after rebuilding, you will see that here at the bottom, we are getting those information about that it was truly changed, that app-config from the Tekla installation directory was used. Just to show you that without that line, we were not able to correctly patch our unit tests. So this is a hack. I don't recommend it, for your all of your projects, but just for the purpose of getting better insight. Okay, so in the debug it was 23 seconds, and in the release it will be something about, let's see. It's still not the better, the best, the recommended way how you can measure the performance. But yeah, I just want to have something. So now we will see that it will take, let's see how much. So in the release, it took almost the same. There was no improvement. Once more. Okay, so we don't see any difference between the release and the debug. Quite strange, but we are testing the performance based on the unit test. So we are mixing two different words. So this is not how you should do this if you want to truly find out why your application is so slow. So I rather suggest to go a little different route. So I want to create a completely new project. It will be the exe application, which we will target with the profiler. So there is a tool built inside of the Visual Studio, also that community edition, which can help you to find out what is the hot path, what takes the most time in the execution of your code. And that will be something which I want to show you, because I feel that it will be the best way how you can check it. So now I'm just restoring, going back to the debug mode, removing the hack for the release mode, because it doesn't help us at any point. So let's try to create the new benchmark application, which we will use for the performance profiling. Okay, so as I said before, we need a new project in our solution, and it will be the first executable in that. So let's create a new application. It will be the console app, and I will create it using the new .NET, but later I will switch with the CS Pro to target .NET Framework 4.8. And now let's stick with the same naming convention. So dotbim, Tekla, and benchmark, just like that. Okay, it will be created in that directory. Sure, let's go. Okay, I will use .NET 5. Now it doesn't matter. I have it now set up. And the first thing which I will do is just changing it for .NET Framework. What was the schema? Let's see in the integration tests, because it was .NET 4.8, just like that. Okay, so I will create it like that. I will try to rebuild just to be sure that it will work. And I see that there is some error. Why? Something. So let's just clean the solution and try once more, because that change is quite a big one. So now I see that the club benchmark project assets JSON was not found, but I don't need those analyzers. So okay, I will try to rerun the solution. So it is now, and now let's try to rebuild, and it should work. Yes, so changing the .NET from the newest one to the old one, probably it will need restarting of the Visual Studio, but it's not a problem. So now we have it, and let's just open it, and yeah, we have the hello world, nothing fancy. So let's try to invoke our dotbim exporter from our exe. And for that purpose, I will add a project reference to dotbim engine. And inside of my main method, I want to create that exporter. And where it was, it is, I will just copy that method and provide it somewhere here. So here, export sample. Okay, so let's here try to export data, and that method is not static, so I will just try to squeeze it like that. Okay, and it should not work. So let's be sure that it will not work. And yeah, we are getting error that we can't connect to the Tekla. So here we are going again with the same TS, what was the name of that library? TS app config patcher task. We need to get it, or to try to reuse those targets, or fix it with the app config. There are different ways, but I will still try to use the same as Tekla DevOps guy is recommending, because I see that he spent quite a lot of time to do it in a best possible way. And it's not his fault or Trimble fault that migration to the newer .NET version, it means that the GAC is not available there. So now I have added that package. Here it is, and I hope that it will work. So now okay, the exporting is invoked. And yeah, I'm just watching to the memory because I feel that suddenly, yeah, we are allocating a lot of points. We are creating a lot of geometry. So, okay, yeah, we are getting almost 300 megabytes probably in our RAM memory, but in the end, we have it. So now we see that in the debug, it took almost 20 seconds. So quite similar to what we have obtained during the unit tests. Nothing better. And now I want to go to the release mode, and it will not work as previously because I need to add this Tekla version. Yeah, let's just see that it will not work. Yeah, there is the problem that you can't fully debug when the code is released with a release configuration, but okay, I just want to get that exception. Yeah, Tekla is not there. Great. So now let's add the Tekla version. I'm not sure what was that, but probably just Tekla version, and it was 2024.0. So it should be enough just to patch it. I am always checking it here, that yeah, it is here. And the second way how you can check that the patch was applied or not is to go into your directory and see that there is the exe.config file, which will be quite big for those files. So now I will try, yeah, here it is. And now I see that those libraries which are coming from Tekla, they were patched. I have not touched that area. So this part is not coming from my side. I have not added app.config to that project. It was created with that patcher. Okay, so now it will work, and I will run it like that, just to see how long it will take, the same operation of exporting the whole model to the dotbim format. So let's wait. It should be quite the same, 17-20 seconds, something like that. And when we will have the release mode working, then it will be time to try the profiler. So okay, so we are getting 19 seconds. And of course, it's just one operation. We don't know how Tekla is caching the geometry. Probably it is not caching it. And yeah, measuring the time just by one try is not enough. But okay, for that we will go later. Now I want to do the profiler. So I will go into the debug, go to the performance profiler, and the question is what we want to check. And of course we can check the allocation, which is quite important, and for our creation of every point, every time, it will, yeah, those numbers will be probably very big. But for now I just want to look into the CPU usage and the memory usage. That's all. Here you can provide the project which you want to create, and that's why I created the benchmark project, because I wanted to have it as a separate one. So now I will try it, and the profiler is executing our code. It will take those 20 seconds as previously, but as you can see in the background, we are collecting quite a lot of data, and we will see the hot path. So we can very easily see which method, which class is responsible for this slugginess. So it took 20 seconds, okay? But what was the problem? And now we see that, okay, memory, but I want to go to the CPU usage, and here it will be the chart. It's not very informative, but if you go open details, then the magic will start, because here you will see what spent the most time, the most CPU time. Our operation is very CPU heavy. You know, we are not reading anything from some database, some file. Okay, of course, the last step is writing to the file, but yeah, on my SSD it's not a problem. So here you can see that that method, export sample, it is responsible for almost 97% of the CPU. Nice. Of course, it's not very, you know, it's not a miracle to find out that, but we can go deeper. And here we can see that, okay, inside of our export, what is the split between different operations? And here you will see the same as we were trying to do with those system diagnostic stopwatch, because we marked those points that we want to measure that operation, that operation, that operation, and at the end we were trying to display those times. So that is exactly the same what we have tried to do, but we needed to think, okay, so where we should look, what steps could be critical to our performance. And when you are using the profiler, then it do it for you. So you don't need to think ahead, okay, so probably that operation will be the most time consuming. And what we see here, let's just try to make a little more space. That method is the worst one. And we know that before using the stopwatch. But I am very curious, okay, so what exactly was inside of that? So when we go one step more, then we see that, okay, so that method, it is responsible for almost 50% of our CPU. So half of those 20 seconds is because that method was invoked. So if you would like to squeeze the time to as least as possible, then you should look into that method, because here, the cake is the biggest one. So if you can trim it, make it less, then you will feel the difference. And then meshing, so the tessellation, this is the thing which I was a little afraid that maybe it will be the bad side of our code. It's not so bad. It's just, someone could say that it should be 5%, not 15%, but for me, it's not so bad. We see that getting the color is responsible for almost 7.5% of the overall time. But okay, let's go deeper into that transformation. What exactly is happening inside of that part of the code? And here we see that almost all of that method is occupied by that get face enumerator. And what is that method? Who have written it? Let's look. And get face enumerator is coming from the Tekla structures model, I think, or maybe Tekla structures. So this is the part where your C# code is trying to connect to the Tekla engine to get those solids. So here is some delegate proxy. There is some type of a connection of a named pipe between your app and the Tekla, because Tekla engine is built with C++. You are not working in a C++, so there should be some mechanisms to talk from different softwares, from different languages. And it is provided by the Trimble itself, so we can't do anything in terms of how that method works. It's like that. We are just asking about almost 10,000 of different geometries, 10,000 of objects, so it has to take some time. It could be slower, it could be faster, but we don't have the magic power how that part of the process can be boosted, can be calculated faster. It's beyond our scope. But is it really? I will try to expand that topic a little more just in a few minutes. But I wanted to show you that it is very fruitful to try to do the performance profiler to see where exactly your application is spending the most time. Because I was thinking that okay, maybe those points, maybe it should be the struct. Yeah, of course, probably I will save 10% of those 20 seconds. But if it will take 18 seconds or 20 seconds, what is the difference? And the time which I will need to rewrite the existing code will be quite significant one. Maybe I will do this, I'm not sure at that point, but the performance profiling will show you that, okay, hey, it has to work like that. You don't have the control over that part of the code because it's just a matter of talking with some other software. That's all. You are not sitting inside. And this is exactly the point. We are not sitting inside of the Tekla. We are starting to, we are triggering the exe application or some unit tests, which are sitting just behind or maybe by side of the Tekla structures. We have not yet wrapped our exporting of the dotbim into the plugin. And here is the place when the true magic will happen. Because now we are suffering the performance bottlenecks because of that connection from the exe application, our app, and the Tekla. So there are two applications and they have to talk somehow. But what if we could put our app inside of the Tekla? We are just a smaller brothers of Tekla. We have built it on top of their shoulders. So why do we need that exe? And this is exactly how we will solve that performance issue. So I will not recreate the code. I will not, think by today is how I can do anything with that method, which is heavily related to internals of the Tekla, because there is a better approach. I wanted to develop that dotbim exporter as a plugin, and I wanted to do this exactly because of that. Because if something sits exactly under the Tekla process, the querying the model, getting the properties, getting the geometry will be much faster. How much? We will see, of course, because we need that plugin. We have not created it yet. But just from the profiling, I see that the problem is with the communication with the Tekla. So let's try to improve that communication. Let's try to set our plugin, our app as a plugin inside of Tekla. So let's do this. But before I will do this, then it's quite problematic to trigger the profiler into the Tekla and measure your plugin in real life. It's not so easy as when you have it separated as an exe. So probably I will not use the profiler when we will switch to the plugin. But I still want to see, okay, so what are those times? How it changed? So to do that, I will go back to that exporter, where it was. It is somewhere here, okay? Here, and here we have created something console write line. And of course, the console write line, when the code will be wrapped as a plugin inside of Tekla, it will not work because there will be no console to show some data. So now I just want to write it down to some file on my hard drive. Some kind of a very simplistic logging. Sorry for simplicity, but I just want to have that somewhere. So I will append the text, and I want to append it to some path. Let's just create, I think that the test file, this test.bim file, it was somewhere here. So let's into the same directory also place the benchmark. And let's save it as a text, and here we need to provide the content. So now I want to provide the message, but probably we will be appending. So every time we will invoke the plugin, we will store how long it took. So let's just here or maybe here, not just provide a new line. Okay, and why I have done it? I don't need those diagnostic sessions. For now, it's all what I wanted to do with the profiler. Now I will just try to run that exe just to see that here there will be the test.bim file, but also the benchmark text to see that those times will be written, just to have some visibility. Okay, so how long does it took? Because I don't want to measure with some clock or phone or whatever you would like to do. So now let's wait those 20 seconds, and we see that there is a new benchmark text file. Let's see it, and here it is. So we have that information coming from the release mode. Okay, nice. And this is the first step, just to create the plugin from scratch, because I will not stick too much about the UI itself, but I just want to have some WPF, very basic one, plugin, which I will copy paste into the Tekla extension directory, just to see that it took this and this, just like that. So I will do it on my own, and I will be back when the project will be set up. Okay, the new project and dotbim Tekla UI was added. I have done it, and it was quite a trouble, because I had to change the namespace convention, because before it was like that, dotbim, Tekla, something. But unfortunately, due to XAML limitations, XAML is something which is visible here in the definition of the UI in the WPF. So there was a problem that here you have the Tekla, which is used for the definition of the plugin window itself, and also for those fancy header and footer. And there is also the Tekla sub namespace in the previous. So the XAML was not aware of the distinction, and I checked that I have no influence over that. I cannot, specify some global namespace. It doesn't work. I found some problem on the GitHub related such a thing, and yeah, they know about that, but they are afraid about changing. So there is only one advice: just change your naming convention, and I had to do this. So yeah, now those projects are named dotbim Tekla without the dot between those two words. So we have the plugin, very simple one. This is the non-dependent plugin, so it don't need picking anything in the model. Now it works just with what is already selected, and it is targeting the same file on the hard drive. So I just want to measure the time, how long the export will take when our code is inside of the Tekla process. So let's find out. I will select as previously all of those model objects, and here I have the dotbim export. And yeah, the UI there is no UI, it's just a simple modify button which triggers the exporting. And now the export is happening, and previously it was something about 20 seconds. Now definitely it was much shorter, but how much we will find out after checking that file, because here we have it written like that. Previously, when it was just the executable, so the outside process which has to connect to the Tekla and get all of the data, it was something about 20 seconds. Now we were able to decrease it to 5 seconds. And if we compare the times, there were three distinct phases. So at first we were querying what is already selected in Tekla. Please see how huge is the difference when you are asking the Tekla, hey, what is selected when you are outside of the Tekla process and when you are inside, and getting the solids and getting the triangles. Now it is only 3 seconds. So I am pretty sure that if I would stick into the tessellation procedure and try to optimize that part, then the time will be maybe something about 3, maybe something about 4 seconds. So this is something what can be achieved if we will go into the optimization in our part. Because when I placed my code as a plugin, I have done what I could in terms of the communication with the Tekla. Now we are inside of the Tekla process. So those operations heavily relying on the Tekla capabilities, they are much faster. You know, those differences are significant. You would not be able to get so big boost by just converting classes to structs or doing some other optimization techniques. And yeah, we see that almost half of that operation was took by just serialization that file to the JSON. And as we can see, that JSON is quite big. It's almost 90 megabytes of data. So that is the main conclusion, that please try at the very beginning to provide your application in a different way, to not provide it as a separate executable, but think, okay, maybe it could be the plugin, maybe not the dependent plugin that it will need, placing some new objects in your model, but just as a non-dependent plugin. I always prefer that method for operations which are very heavily relying on the Tekla database. When we are asking about a lot of objects, like here, because we are here asking about all of the parts. Of course, when we will go to the rebars or to the welds or other objects, maybe not welds, maybe just bolts, and then those times will be much bigger. Unfortunately, it will be not just 5 seconds to get the dotbim export. But yeah, that's what will be what I need to do on my own in the next days. For now, that's all. I don't see the purpose to try to squeeze the time more. Here, there is one not touched topic, because we are not asking about any properties. So I have to think, okay, maybe I can reuse those additional property sets, that one, and that big list. How it is get, where are those XML files which are specifying, okay, so which entities should be done like that, and how I can just reuse the same principles if it isn't possible. I don't know. I have to check it, but yeah, it won't be recorded. I will not place new videos about that. I want to create 2 more videos. So the next one will be about the UI, how to set up the WPF plugin, and yeah, now it's empty. So I will just show you some basic data bindings between the user control and the fields behind. And the last video will be about the releasing your application, providing it to your users. So we will try to create that SEP, just a single one file installer, which can be placed in some Tekla directory, and then it will be automatically installed when the user will trigger the Tekla, or they can manually double click and the whole operation will go smoothly. So there will be 2 more videos, and for the optimization part, that's all. I will not change the code because based on load times, I don't think that it makes sense. So we will see on the next occasion.